Chapter 3. How to calculate present values. How to evaluate long-lived assets. How do we evaluate assets which produce cash flow several years? We already know the present value of an asset that produces a cash flow C1 1 year from now is present value is C1 divided by 1 plus the interest rate. With 2 or more years, we get this. The present value of 2 and more years is present value equals C2 divided by 1 plus the interest rate to the second power. This is, if you have several years, the sum of the cash flows T divided by 1 plus the interest rate to the power of T. This includes a big assumption. Interest rates are constant over time. What happens when you have different interest rates in different periods? The discount factor declines as futurity increases. $1 tomorrow is worth less than $1 today. That's why $1 the day after tomorrow should be worth even less. And we can say the discount factor 2 is less than the discount factor 1. How about the money machine? Is there such a thing? No. 2 identical assets must sell for the same price. Otherwise, investors could make arbitrage profits by buying the cheap asset and selling the clear one. Here we see an example. What is given? We have 2 periods. The initial payment is $120,000 for construction. We will construct an office building. $50,000 for the land. The progress payments after 1 year is $100,000, and the final payments will be $100,000 as well at the end of the year 2. The building will be worth $420,000 at the end. The interest rate is 5%. For a better understanding, here is a table. So, if we use the formula of the net present value, we will get a plus of 25,011. So we will do the project because it has a positive net present value.
Looking for shortcuts, perpetuities and annuities. How to value perpetuities. The annual rate of return on a perpetuity is equal to the promised annual payment divided by the present value. So the formula would be the return equals to the cash flow divided by the present value. Now we can twist this around and find the present value of a perpetuity given a discount rate R and the cash payment C. So it will be present value equals cash flows divided by R. So the perpetuity formula tells us the value of a regular stream of payments starting 1 period from now. Examples of perpetuities. Consols. These are bonds that the government is under no obligation to repay, but that offer a fixed income for each year to perpetuity. Applied example of a perpetuity. When a billionaire wants to endow a foundation that does researching to combat malaria and starts providing $1 billion starting next year, if the interest rate is 10%, then the formula would be 1 billion divided by the 10% equals 10 billion. How to value annuities. An annuity is an asset that pays a fixed sum each year for a specified number of years. Examples: equal payment house mortgage or installment credit agreement. So the present value of an annuity would be 1 divided by R minus 1 divided by R times 1 plus R to the T power. This is also known as the T-year annuity factor. But is there any way to explain how we got this formula? Yes, this formula is also equal to the difference between 2 perpetuities. For example, we have a perpetuity A that pays $1 from now till forever, and the present value for that would be 1 divided by R. And we have perpetuity B that pays $1 starting from year 4 to eternity, and that formula would be 1 divided by R times 1 plus R to the 3rd power. And then we have a 3-year annuity that pays $1 from year 1 to year 3, and the formula for that would be the first perpetuity formula less the second perpetuity formula. So here we prove that an annuity that make payments in each of years 1 through 3 is equal to the difference between two perpetuities. Example of an annuity costing an installment plan. Suppose they offer you an easy payment scheme to buy a car, where you have to pay $5,000 at the end of each of the next 5 years with no cash down. What is the car really costing you? If the interest rate is 7%, the present value equals 5,000 times 1 divided by 0.07 minus 1 divided by 0.07 times 1.07 to the 5th power. That's equal $20,498. Second example, a group of friends won $295.7 million on the lottery. The sum was to be repaid in 25 annual installments of $11,828 million each. Assuming that the first payment occurred at the end of 1 year, what was the present value of the price? The interest rate at that time was 5.9%. These payments constitute a 25-year annuity. So, to value this annuity, we multiply $11,828 by the 25-year annuity factor. Here it would be 11,828 times 1 divided by r minus 1 divided by r times 1 plus r to the 25th power. So this is equal 12.9057 times $11,828, and that's equal $152.6 million. How to calculate present value annuities, annual payments, and future value of annuities. Present value annuities due. Annuity due. Level stream of payments starting immediately. Is worth 1 plus the interest rate times the value of an ordinary annuity. So if we discount its cash flows by 1 less year, the present value is increased by the multiply of 1 plus the interest rate. Second, calculating annual payments. We can take an example by finding mortgage payment. If you take out $250,000 house mortgage from your local savings bank, and the bank wants you to repay the mortgage in equal annual installments over the next 30 years, so we must set the annual payment so that they have a present value of $250,000. The formula of the present value is mortgage payment times year annuity factor, and the formula of annuity factor is 1 divided by the interest rate less 1 divided by the interest rate times 1 plus r to the power of n. Solving the problem. So if the interest rate is 12% a year, the present value would be $250,000. 3 years annuity factor will be 8.055. The mortgage payment would be $250,000 divided by 8.055. This is equal to $31,037. The mortgage loan is an example of amortizing loan. Future value of an annuity. Example: if we want to set aside $20,000 in each of the next 5 years, and the earn of the return is 8% on the saving of $20,000, the present value is the $20,000 times 5 years annuity factor. This is 20,000 plus 1 divided by 0.8 less 1 divided by 0.8 times 1.08 to the power of 5. This is equal to $79,855. So the formula for the future value of annuity would be 1 plus the interest rate to the power of t less 1, all this divided by the interest rate.
More shortcuts. Growing perpetuities. For value a stream of cash flows that grows at a constant rate y represents the growth rate for the present value formula. Present value equal to C1 divided by R less G. For example, if we have an investment plan of 10 million, but you don't consider the growth rate G of 6% a year starting in year 1. providing 1 million a year in perpetuity, year 1 we have a C equal to 1 million. So we have an investment of 10 million, a C equal to 1 million, and R equal to 10%, and a growth rate of 2%. The present value is equal to 1 million divided by 0.10 less 0.06, and that gives us a present value equal to 12.5 million. This is the amount that you need to assign today. Annuities. For an example, annual membership. The annual memberships dues for the coming year are 5,000, but you can make an upfront payment of 12.750 thousand, which will provide you with membership for the next 3 years. What is the best option? It depends on the growth rate. Option 1, fees payables at the end of each year. Year 1 you pay 5,000, and year 2 and year 3 5,000 also. In the option 2, membership for the 3 next year, G equal to 6% per year, R of 10% discount rate. How to calculate the 3-year stream of cash flows? Growing 3-year annuity. For this formula you have to do this. Growing perpetuity A less growing perpetuity B equal to growing 3-year annuity. And that is the formula. In our example, present value is equal to 13.146. So the option 1 we have a present value equal to 15,000, and in the option 2 we have a present value of 13.146 thousand. It would be better if we pay now for a 3 years membership.
Compound interest rates and present values. There is a big difference between simple interest and compound interest. When we have compound interest, each payment of interests is being reinvested, so the interest rate that we apply is now calculated over a larger amount of money. We can see that simple interest will pay the same amount every period because the interest is calculated over the same first amount of investment. So we lose the opportunity to win interest over interests. Annual percentage rate. This interest is the one that banks and other credit companies should be based on. For example, if the interest rate of your credit card is 1% per month, then the bank should be trading an annual interest rate of 12%. But this is different from the effective interest rate. Compounding intervals. We have assumed that every future cash flow happens at the end of 1 year, which is not always that way. We can collect interest monthly, semi-annually, quarterly, etc. This depends on the contract of the financial element, bond, credit, etc. So, an investment of $1 at a rate of R, capital symbol, M times a year is equal to 1 plus R divided by M to the power of M. We are going to have an annual interest rate and the compounding intervals, so we calculate the effective annual interest rate with 1 plus R divided by M to the power of M minus 1, being M the number of compounding intervals in a year. Continuous compounded interest. In this case, M is infinite, so when M tends to infinity, 1 plus R divided by M to the power of M approximates to 2.718 to the power of R, which is the same that E to the power of R. That is on the first year. In the next periods, it would be E to the power of R times T, T being the number of periods.